perpendicular to, it gave you two things it's perpendicular to, right? So x minus y plus z equals what? 5.
5.
And
2x plus y
minus 2z.
2x plus y minus 2z equals 7. So to write the equation of a plane, you need two things. What do you need?
Normal
You need a point
and a point.
and a normal, right? What do they give you right at the beginning here?
Normal.
Nope. They give you the point directly. Like, we have the point. Yay, that's very nice. Do they give you the normal vector, like, just directly? They don't. But they say they want something, they want this plane to be perpendicular to both of those planes. They want to be perpendicular to both of those planes. So how do you go about making something that's perpendicular to both of those planes? I don't understand what you're saying. You're saying I should take, if I take this right here, and you're saying to make, what, 1, -1, 1? Is that what you're saying?
Yep.
And then I take this one right here, and it's 2, 1, and what? So what are those two vectors? What is this vector in relation to plane A, and what's this vector right here in relation to plane B?
They're the normal vectors of each respective.
They're normal to both of them, correct? They're normal to both of them. So if you had these two planes sitting in space, if you had these two planes sitting in space right now, so here's one plane, and here's where they intersect. So you have these two planes right here. It's not bad. I kind of messed it up at the end there, but doing okay. So you have these two planes, and you have the component form for two normal vectors right here. You have this vector right here, and you have this vector right here. These planes are not necessarily perpendicular to one another, are they? No, they're not necessarily. I just drew them that way by they're arbitrarily. They do these two planes A and B have to be perpendicular to one another? No, but you have these two vectors. So if these were extended like this, and then you cross them, what do you end up with? You end up with a vector that's perpendicular to both of them, perpendicular to the plane you want. Like, you can actually see the plane you want. What's the plane you want right now? You want like this plane right here, right? Like, that's the plane you want, right? Yay, that's the plane you want right there. So how do you write the equation of the plane you want? You need a point and a normal vector. Well, you get the normal vector by crossing those two. So if you're going to set these up, I, j, k, what's the first vector? 1, 1, -1, and 1, and then 2, 1, and -2. You cross them, and then you end up with something I, right? Minus something k plus, sorry, I, j, k, I don't know why I skipped that. J plus something what? K. So those are your components right there, right? So you do all those 2 by 2 determinants. And then once you get that, what do you have? You're really just interested in what three numbers? The final numbers right here, here, and there. Because what is the general equation for a plane? What's that nice equation? A times x minus x naught plus b y minus y naught plus c times z minus z naught equals 0. And where's a, b, and c? That's a, that's b, and this is c. And you already know what x naught, y naught, and z naught are because they gave us a point. Those are going to be 0, 0, and 0. So then once you get those three numbers, I'm not going to do the cross product, but do you understand the basic picture of what's going on here? The key thing is the original two planes are not necessarily perpendicular, which doesn't change anything, but don't assume that from my picture. We need to write a vector, we need a direction and what? What are the two components in a vector? Direction and magnitude. You need these two things, right? Direction and magnitude. So what is the magnitude going to be equal to? They want it to be equal to the area of the surface, right? So in 43, it says the surface is the circle of radius 2 in the xy plane. So circle of radius 2, what's the area of that? Pi times 2 squared, so it's what? 4 pi. So do we know now the magnitude of this vector? Yes, it tells us we're making a vector with magnitude equal to the area of the surface. What's the area of the surface? 4 pi. So we know the magnitude we want, and now it says facing in the direction of the positive x-axis. So in 3 dimensions, we have z right here. We have the positive x, and we have the positive y. So it says we want it facing in the direction of the positive x-axis, right? So what's it going to be?
A positive I.
It has to have a magnitude of 4 pi. So 4 pi, comma, what? 0, comma, 0. Done. This vector, what's the magnitude of that vector? 4 pi. Exactly. It's the square root of 4 pi squared. 4 pi. What direction is it going in? It is going in the direction of the positive x-axis. Now, could we have moved this vector? Does this say anything about where the vector is starting? No. So this vector could be floating anywhere, but what direction is it going in? In the direction of the positive x-axis. If we wanted it going in the direction of the positive y-axis, it'd be 0, 4 pi, 0. The positive z-axis, right? This is the comprehension question. It's not necessarily about the altitude in a direction. Do they give us the direction? Oriented upwards. Oriented upwards. So upwards is in the direction of what axis? Equals k-axis. So k, not axis, but k, what? Direction. What's the axis?
Z.
Yeah, z. Okay, so what's really the only thing we need to find here? We know it goes up, so it's going to be like 0, 0, the magnitude, right? So what do we need to find the magnitude here? The area of that triangle. The area of that triangle. How do you go about finding the area of that triangle using multivariable calculus? Yeah, half of the cross product, right? So you want to do something, let's just say it right here, half of, let's say, AB cross AC. Yeah, because the cross product is the area of the parallelogram, right? Parallelogram in the 3 dimension is parallelepiped, which still sounds weird, I know. So this is what you're looking for right here. So do we need to do that, or could you do that on your own? So, I mean, the answer to this is going to be 0, 0, this number, right? We good? Does that make sense? Ting dong ah. So what they want you to do is, how do you find the direction? If this is a triangle ABC and it's tilted a little bit or a lot, right? One of them is generally considered up and one of them is generally considered to be down. How do we figure out what direction this is? How do we figure out what direction up is? It's perpendicular to these two vectors, so how do we figure out what up is?
Find the normal vector.
Yes, how do you find the normal vector?
Crossing.
Crossing them, right? You cross them. So for example, in this diagram right here, what would up be? Up would be the direction, the up direction would equal what? In this case, oh, well, I put it at B, so what would it be? BA cross BC. Oh, and be careful about that though. If we cross BA then BC, would that be up? If this is up right here, if this one is up, if that direction is up right there, that's down, right? So what would we really need to do? BC cross BA. Now when we cross these two things, we get that's a scalar, right? When we cross them, right? How do we know the direction? So we cross them, and if you want to find our parallel right here, how do you find our parallel right there? Or how do you find the magnitude of our parallel right there? This is our parallel. What's the magnitude of that equal to? You have to know this immediately. R dot what? Is it R dot F?
No, it's a unit.
R dot products are scalar, right? Dot F, right? But it's F divided by what? Of F. Some people did this, and instead of dividing by the magnitude of F, what did they divide by? Magnitude of R. Like when R is being projected onto here, it needs to be R at like that. So some people, they did the dot, which is great, and it gets you like 11, right? But then you need to divide by the dot of the direction you're going in, right? And it's just reading comprehension and understanding which goes where and being really careful about it. So is the math the hard part here? Not really. That being said, the words I can't say words are not math, they are. Like you have to be able to understand what's going on here. Does that make sense? So that's the magnitude you want. What direction are you going in? The F direction, right? So you would then multiply this by F over, because this right here is the unit vector, right? This is the direction you want, right?
In the direction of the.
Does that make sense? You kind of with me on that right there? A little bit? It's sort of with me? Okay. Okay, so I think